All right, so in lesson 4.6, we're going to talk about congruence in right triangles. And this is the last theorem that's actually on our foldable sheet we made with SSS, SAS, ASA, AAS. This is a theorem called hypotenuse leg, or for short, HL. And this is a theorem that only occurs in right triangles. So the theorem says if the hypotenuse and a leg, so only two parts of one right triangle, are congruent to the hypotenuse and another leg of a different right triangle, then the triangles are congruent. So this is the criteria. If these two triangles, PQR and XYZ, are both right triangles, and PR is congruent to XZ, that is each of the hypotenuses. So the hypotenuse in a right triangle is the side that's across from the right angle, the side that is opposite from the right angle. PQ and XY are legs. Now it doesn't matter which pair of legs are congruent as long as one pair of legs are congruent and the hypotenuses are congruent. Those triangles are congruent by what we call HL. So to talk about that, for example 1, we are going to do a short proof, and we are given that PRS and RPQ are right angles. SP is congruent to QR. We want to prove that PRS is congruent to RPQ. So to prove this, I'm going to use a two-column proof, the proofs that we are most familiar with. So I'm going to draw my two columns. And my two columns have statements on one side, reasons on the other. So my first statement is angle PRS and angle RPQ are right angles, and that is given. Okay? Also, SP is congruent to QR. That is given. Okay? So what I can further say from what is given is I can say that PRS, triangle PRS, and triangle RPQ are right triangles. They are right triangles, and that is because the definition of a right triangle is, I'm just going to abbreviate definition. Definition of right triangles. That definition says if a triangle has one right angle, then it's a right triangle. So that's important because that's part of the criteria for HL, for hypotenuse leg, to prove these are congruent by hypotenuse leg. The next thing I can say is that PR is congruent to RP. So PR is congruent to itself. That is by the reflexive property, and I know that I ran out of room. So I'm just going to, off to the side, do the final thing I can, say. I can say that triangle, give myself a little more room, triangle PRS is congruent to triangle RPQ, it's supposed to be R, by HL. So essentially using the same properties we've talked about before, but using it to prove a new theorem, hypotenuse leg. So the three criteria, both the triangles have to be right, hypotenuses have to be congruent, and one pair of legs has to be congruent. So part B of this says something about your friend making a statement that you have two right triangles with congruent hypotenuses, so they're right triangles, that's the first criteria. Congruent hypotenuses is the second criteria, and one pair of congruent legs. And what your friend says, it does not matter which leg in the first triangle is congruent to which leg in the second triangle, the triangles will be congruent. And my answer to that, if they're correct or not, I would say yes. And the reason is the two triangles satisfy HL. And the main thing I want you to get from this, to explain, you don't have to add this to your explanation, but it doesn't matter which two legs are congruent, as long as a pair of legs are congruent in that triangle. And remember, the legs are the sides that are not opposite the right angle in a right triangle. So for example 2, we've got another proof, but we are not just filling in blanks, we're completing the entire proof. So I'm going to start this proof with what's given. BE bisects AD at C, and that's given. AB is perpendicular to BC, and DE is perpendicular to EC. That's also given. Okay? And the last thing that's given, AB is congruent to DE. So AB is congruent to DE, that's also given. Now I go to the things that I can assume from this triangle. The first thing I'm going to say is I'm going to take care of that BE bisects AD. If BE bisects AD at C, that means C is a midpoint of AD, which means AD is being split into two congruent segments. So I can say AC is congruent to DC because that is the definition of a bisector. We talked about bisectors before. Bisectors cut things into two congruent parts. So I can assume that AC and DC are congruent. Next, I have to go about proving the two triangles are right triangles, because that's part of the criteria for HL. So the first thing I would have to say is that the two angles are right angles before the triangles are right triangles. So I would say that angle ABC and angle DEC are right angles, and that's because of these perpendicular symbols. That is the definition of perpendicular. And I know that's weird, but we are doing these proofs to help us remember different properties and to reference those properties. Okay? So since those triangles are right triangles, I can say that triangle ABC and triangle DEC are right triangles. And that's the definition of right triangles. So through all that, we can now say that ABC is congruent to DEC because we met all the criteria for hypotenuse leg. We met all of the criteria for hypotenuse leg, right? So some of this stuff, like definition of bisector and definition of perpendicular, we have to remember we got to kind of add extra information sometimes. So we'll get some practice with that. I will maybe throw in fill in the blanks on a proof on a quiz, so just be prepared for that. We will review it, but just be prepared to complete some proofs when we get to the quizzes. And then the last part is another thing that I throw on a quiz is maybe a 1 or a 2 level type of question, but are the triangles congruent? And if so, we'd write the congruence statement. So we'd have to think about, does it fit all the criteria? For number 1, the triangles are right because the angles are marked as right angles in those triangles. 10 and 10 are hypotenuses, 6 and 6 are legs. So I would say yes by HL. So writing the congruence statement for these two triangles. Triangle ABC would be congruent to triangle, and it's important that these sides match up, DEF. Okay? So if they're congruent, write a statement. That's what we're doing. All right? Number 2, these two triangles are right because these angles are vertical angles, so they'd both be right angles. So I'd say yes by HL again. And then my congruent statement, triangle, and it's really your choice. I'm going to say LMP is congruent to triangle OMN. Okay, OMN. Number 3, does it fit all the criteria? I would say no. Two pairs of sides are congruent, but the triangles aren't right triangles. These angles would have to be marked as right angles for this to follow HL. All right? And then finally 4, I would say yes. That is because RV is congruent to itself by the reflexive property. So yes by HL. And then my congruent statement, I would say triangle R, XV is congruent to triangle RTV. So, both triangles have to have right angles, hypotenuses have to be congruent, and whichever pair of legs that are corresponding have to be congruent. So, ready for some practice? We can move on to that next.